Hello and welcome to today's video. Today's video is for Advanced Geometry, Chapter 10, Section 3, Areas of Regular Polygons. So what we're going to do is we're going to have some definitions, and I'll show you the formula for finding the area of regular polygons and also derive it for you. So in order to find the area of a regular polygon, we need to know what the radius is. The radius is from the distance from the center of the polygon to a vertex. So this would be a radius. And then we also have something that's called the apothem. The apothem also goes from the center, but it goes perpendicular to one of the sides. And if this is, if this is a regular polygon, this is also going to be a midpoint. So it's a perpendicular distance to the center of a side. So this would be the apothem. I've heard it said apothem. I've also heard it said apothem. However you want to say it, either one of those is fine. There's one more thing, and this goes back to something we did before. We also have something that's called the central angle. So if we make an angle to the center of the polygon and two of the vertices, then this will be the central angle. So that's something that we've had before. So the figure at the right is a regular pentagon with radii and an apothem drawn. Find the measure of each numbered angle. So one of the formulas we learned before is that if we go all the way around a circle, it's 360 degrees. And if we want to find one of these central angles, then there's going to be the same number of central angles as there are sides. So if we take the number of sides and divide by, if we take 360 and divide by the number of sides, then we can find the angle measure of each central angle. So this is a pentagon, so if we do 360 divided by 5, and that's going to be 72. Okay, so angle 1 is the central angle, so the measure of angle 1 is 72 degrees. And then also what we have is the apothem is going to split, as long as this is a regular pentagon, it's going to split these into two congruent right triangles. So angle 2 is just going to be half of that 72 degrees. So it's going to be 36 degrees. And then if we take a look at angle 3 and angle 2, they're going to be supplementary. So if we take 90 minus 36, that'll be angle 3. So the measure of angle 3 is just going to be 54 degrees. We're going to need to be able to do this because we might need to use trig to find the apothem or maybe a side length. So one of the things that we're going to do a lot is to take the central angle and then draw the apothem and then be able to find some of the angle measures. Next we have the formula. The area of a regular pentagon, the area of a regular polygon is half the product of the apothem and the perimeter. So again, I want to derive this formula to show you where it comes from. It's kind of, if you think about it, kind of very similar to the triangle formula, 1/2 base times height, except for what we have is we have a bunch of triangles that we're going to put together, and each one of those triangles is going to be 1/2 base times height. So I'll kind of show you where that comes from. So I'll draw any polygon. So I'll draw it kind of like a hexagon, but know that it could be any number of sides. So maybe I'll just draw part of it. And then what I can do is I can draw the central angle. Okay. So what's going to happen is what I could do is I could break this polygon into a bunch of congruent triangles. And those congruent triangles would have a base of one of the side lengths. So I'll call this S. And then it could also have a height, which would turn out to be the apothem. So I'll label it as apothem. And I'll call it A. Okay. So what we can do is we can say, well, each one of these triangles is going to be 1/2 the apothem times the side length. Well, if we take a look at how many of these triangles we have, we're always going to have the number of sides. So if we multiply this times the number of sides, so I'm going to put area of one triangle, what we can get is we can get the area of the whole polygon. So the area of the whole polygon is going to be each of these triangles times the number of sides, because we're always going to have the same number of those triangles as the number of sides. So let me just rearrange this a little bit. 1/2 apothem, and then I'm going to put the S and the N together. Well, if you take a look, we're going to have a whole bunch of S's going around. Those are the side lengths. And if we take the number of the side lengths times the number of sides, that's just going to be the perimeter. So we can say that the perimeter is just the side length times the number of sides, so we can replace this. And so there we get apothem times perimeter. So if you really want to, you could find the area of one of those triangles and then multiply it by the number of sides. But it's easiest just to remember that the area is 1/2 the apothem, which is the perpendicular distance to the center, times the perimeter. Okay, so some boats used for racing have bodies made of honeycombs of regular hexagonal prisms, sandwiched between two layers of outer material. At the right is an end of one hexagonal cell. Find its area. Now, one of the nice things about a hexagon is it's actually made up of 6 equilateral triangles. So if you want to use the equilateral triangle formula, if you know that, you're welcome to use it. Since we're just learning this formula, I will use this formula. So the area is going to be 1/2 the apothem times perimeter. One of the things I highly recommend you do is you write out the formula. That way it really helps me with grading. So if you write out the formulas, it's correct, and then maybe in the next step you forget the 1/2. I know that you knew the formula and you just messed up when you were plugging things in. That's less points off than if you don't write the formula and you miss the 1/2. I have to assume that you just don't know the formula, and that's a big deduction in points. So I highly recommend that you always write the formula and then you plug in the numbers. It makes it easier for me to grade and see where your mistake was. Okay, so we need to find the apothem, and we also need to find the perimeter. So what I'm going to do is, and I do this a lot, I'm just going to draw the central angle. These polygons can get very confusing when you have all this stuff. So what I'm going to do is I'm going to take the picture and I'm going to redraw the central angle. So we have this. We know this is a 30-degree angle, so we have to remember our 30, 60, 90 stuff. And this is 5. The perimeter is going to be very easy because it's 6-sided and each one is 10. What we really need to find is the apothem. So what we have is a 30, 60, 90. We have the short side. We want to go to the long side. So this is going to be 5√3. You're going to have a lot of 30, 60, 90s and a lot of trig. Okay? If it's a 30, 60, 90, try to use your special right triangle stuff. Try not to use trig, because as soon as you use trig, you're going to be rounding. So area is going to be 1/2. The apothem is 5√3. And the perimeter is going to be 10 times 6. I'll take half of the 6, which is 3. And then 5 times 10 is 50, so it's going to be 150 times √3. So take a look at our units. We got millimeters, so it's going to be millimeters squared. And then at this point, if, since it's a word problem, I'm going to pick up my calculator so that I can get a rounded answer. But I always want to simplify it first as much as I can before I pick up my calculator. So I get 150 square root of 3, and I get about 259.8, so I'll say it's about 260 millimeters squared. Okay. And that's it for today. Thank you for watching. Have a great day. Take care.